In this tutorial, I will show you how to create this procedural roof using PCG Grammar, and it is fully customizable. You can change the angle, move it up and down, and shift it outward or inward. In the previous video, I've showed you how to make the building itself. I've made some adjustments to the graph that made it more procedural and easier to use now. But if you haven't seen that video, I recommend you to watch it because there is so much details about PCG and the new grammar. I also have this project available on Fab, so if you want to have access to it, you can purchase it from here. So for the roof, it starts from right here. So first, in the add attribute, we have a new grammar. In the new grammar, this part right here just chooses if we want to add a trim or we don't want to add a trim, and the trim is this. And so the grammar attribute is going to be first a floor, and that's going to be the floor that has the door. And then we have trim, and that's the trim for the first floor. And then we have upper floors and a trim inside square brackets, and that's going to place upper floors and a trim, and it's going to repeat it as many times as possible because we have an asterisk, and at the top it will add the roof at the end. And that's going to happen by the duplicate cross section. In the duplicate cross section, it's going to take the grammar that we've just added, and it's going to take the modules. The modules we've made procedurally. Now, if we go back and we inspect duplicate cross section, we can see that the last data set is going to be the roof. Before it, we're going to have a trim, and before that, we're going to have upper floors, and so on. And in the next node, we have a spline segment, and this node will place a point in between every two control points of the spline. And from the output of this node, we're going to take a line to the roof part. In the first node, we have attribute filter, and we have the operator matches. The target attribute is simple, and we're using constant threshold. The type is name, and that's the type of the attributes, and the value is roof, and that's the points that we want to keep are the roof points. Now, if we inspect attribute filter, we can see that all of the data sets are empty except the last one, which is the one that has the roof. Now, we only want one data set, so we're going to use merge points, and that's going to merge all of the data sets into one. All of them are empty, so it's going to just keep the last one. Next, we have subdivide segment, and we're using this node to convert the point into a spline, and I'm doing this by making a module that is first point, and the size is very small, and the grammar is just place one first point, and this will place a point at the very start of this segment, so it's going to be right at the control point, and that's going to allow me to convert the point back to a spline. Next, I have the parameter roof adjustment, and it's going into the add node, and I'm adding it to the position Z, and that's going to allow me to move the roof up and down. Next, we have create a spline, and that's going to take each point and it's going to convert it into a control point. Okay, next we have add attribute node, but before that we have some math, and we're going to start with a parameter roof angle, and that's going into degree to rad, and we convert it to rad so that we can calculate the sine of the angle, and then this will be multiplied by 40, and this 40 is basically the hypotenuse. So basically the output of the multiply node is going to be the vertical spacing between the roof tile rows. Okay, next we have the roof modules, and we only have one module, that is the roof. In the next node, we will set the size of the roof, and that's going to go into the duplicate cross section. And the output of the multiply node is also going into this multiply node, and we're multiplying it to this vector. And this vector is coming from the number of roof levels, and that's basically how many rows of roof we need, and we're going to multiply it by the vertical spacing, and that's going to tell us how high the roof need to be, and that's going to go into the extrude vector, which also will be an input for the duplicate cross section. And now the duplicate cross section will make multiple splines depending on the extrude vector, the roof modules, and the size of the modules, and the grammar. We can also see that the output of the extrude vector is going into this subgraph and is taking the parameter roof slide. And this is basically will move the roof outward and inward. And the roof slide, which is this graph right here, is actually taken from the roof loop. So we don't have to explain it twice. We will get back to it when we explain the roof loop. Now we go into the roof loop, and you can see that it's called roof loop manual. And that's because there are some points like here. You can see that they meet each other before this points right here. So we might need to delete them manually. And even though it's manual, it's actually super easy. And I also did make another loop that did that automatically, but it actually did not work that well. That's why I went with manual. So basically this parameter right here will move the control points after we delete, and that's just going to make any adjustments to the SP lines after we delete the points. And this parameter will tell us which point we need to delete, and this parameter will tell us at which level we should delete some points. And we're going to learn more about them when we see the graph of the roof loop. So now let's get into the roof loop. So first, the inputs are right here, and each one are going into a named reroute. So we have the SP line, we have horizontal offsets, and we didn't explain the horizontal offset. So if we go back, we can see that we have the vertical spacing between the roof tiles rows, but for the horizontal spacing, it's going to be coming from this part right here. Here we have create module info, and that's going to make the modules for the rows. And so basically this cover at the edge is a module, and we have the roof tiles module. We have the roof tile that is on the left, and that's going to be a roof tile that is cut from the left, and we have a roof tile from the right, and that's going to be the roof tile cut from the right. And these modules are coming from this subgraph. And in here we have the modules, the meshes. The size is set procedurally, but this is the multiplication of the size, making it larger or smaller. We have mesh placement, and that's going to be the movement of each mesh. We have mesh rotation, and this will rotate the meshes, and that's actually used for the covers. You can see that it's rotated 45 degrees. And we have this scale, and the sum graph, we can see it right here. So if you want to understand how it works, you can pause and look at the nodes. But now from here, from the output of the create modules info, we're going to take the size, and we've created an attribute, and we've moved the first size, and that's going to be the roof tile size, into the horizontal offset. And that's basically going to ensure that each SP line is going to be offsetted by the roof module size, and that will ensure that the roof tiles are aligned with each other. So for example, if this row right here starts at this point, the next row will be offset by the one tile size. Now going back into the loop, we have a feedback, and we're going to explain this in a second. We have adjust position, and that's coming from a parameter outside. We have delete points, also from a parameter, and delete points level, also a parameter. Now from the start, we have the SP line, and we're going to use SP line to segment again. And from here, we're going to use the get attribute from point index, and this is basically we use 1 point to get one attribute value, and we're using it to get the position Z of each SP line, and that's going to be used by the set node to set the position Z of the points in the feedback input. The feedback is basically something that keep rotating through the loop. So for the first loop, which has the loop index 0, the feedback is going to be coming from the graph, and so it's going to be coming from this right here. But for the next loop, the feedback is going to be coming from the feedback output. So for the loop 1, the input of the feedback is going to be coming from the output of the feedback of loop 0. Now if we go back, we can see that we're using the SP line only for the position Z, and we're actually using the feedback to make the roof, and that's basically will ensure that any adjustment we make on the SP line will keep going for the next SP line and the next loops. So basically right here, we've deleted some points, and for the next SP lines, we can see that they also no longer have these points that are right here, because these 2 points have met each other at this point. So we've deleted them. And for the next loops, these 2 points no longer exist. And that's because we are using a feedback. And in the next node, we're setting up a new attribute called horizontal offset. And the value of the horizontal offset is going to be set from the input offset. We're going to directly add it to horizontal offset on the x-axis. And so now we can see horizontal offset x have been set. And on the y-axis, we're multiplying the offset by -1. And that's because we want the points to move to the right. And that's why we need the x to be positive. And we need the points to move back. And that's why we need the horizontal offset on the y-axis to be negative. Going into the next node, we have subdivide segment, and we're making a very small module called first point, and the grammar will only add this first point, and that's basically will add a point right at the start of this segment. So right now this segment is the entire area between the control points. This will make the point just at the start of the segment on the left. Next, we have selecting grammar, and the selecting grammar is going to take the symbol and the previous angle. The previous angle is an attribute that is coming from actually all the way from the feedback, and the first loop, it's coming from roof slide. So if we go to the roof slide, we can see that the first thing we have is SP-line to segment. SP-line to segment can extract the angles. So if we inspect this, and basically this is building number 3, so we were inspecting building number 3, and you can see now we have a previous angle. This previous angle is going to tell us which direction the control points will take the SP line. So this previous angle is going to be for this control point, and this angle will tell us how much the SP line rotated at that control point. So in here, you can see that the control point was going in this direction, and then it rotated -90 degrees to the left. And the next point, which is this, have done the same thing. The third point, which is this, have done the same thing. The fourth point, which is this, also -90. The fifth point is +90. And that's because those are out angles, while this is in angle. And we actually need this to determine the direction of the roof. So in here, for this control point, you can see that the roof is going to the right. Same thing for this one, the roof is going to the right. For this point, the roof is also going to the right. Here it is the same thing, but for this point, the roof is going to the left, and that's going to be determined by the previous angle. Since we are in this graph, we can see that we are also using horizontal offset, and we're multiplying the horizontal offset by -1, and the value of the horizontal offset is going to be set by a parameter outside, that is the roof slide parameter. And this graph is basically just to move the first SP line of the roof outward and inward. But we're not going to explain this because the same nodes are in the roof loops, so it's going to be easy to replicate. Now that we know what the previous angle is, let's take a look at the criteria. In the criteria, we're taking the first point. If the previous angle was less than 0, the output is going to be +1. And if the previous angle was equal or greater than 0, that means the previous angle was positive, the output is going to be -1. And the output will go into an attribute called direction. And that's the output right here. But you can see that the selecting grammar will always output a string. So in the next node, we have bars string, and that will convert it into double so that we can use it in here. In this node, we have multiply. We're going to multiply the horizontal offset x by the direction, and that's again will make this point, and instead of going to the right, it will be going to the left. Next, we are using transform direction, and that basically will allow us to convert the horizontal offset by the transform, which is the position and the rotation and size. And that basically will mean that each point will be moving in its local space. Next, we have an add node, and we're adding the horizontal offset to the position, and that's what allow us to move each point so that we make this shape. Okay, next we have this part right here. So in here we are getting the loop index, and we are comparing it to the input point level, and that's coming from this input right here, and that's a parameter in the graph right here. And this basically means when the loop index is at a specific level, I want you to use this. This right here will delete some points. It is used because there are some points that will meet each other before the others. So these points right here didn't meet each other, but these 2 points did. If we did not delete them, they will overlap. This will go to the left, this will keep going to the right, and they will be overlapping. So we need to delete them. And this right here can be determined by a parameter. So for this building right here, we can see this parameter right here. So if we go 15, you can see that we are deleting the points a bit too early. If we go to 20, you can see that we've deleted the point a bit too late and they already overlap. So if we keep them on 17, we are deleting them at the right point, and that will allow the other points to keep going till they meet each other. And that way we can choose which points to delete is by this parameter. And this parameter right here, you can see that it has 4 elements, and that's the number of points left after we delete points. So basically after we've deleted 2 points, we are left with 4. And the third point, which is this, you can see that we've moved it 40 units on the y-axis. If we did not move it, you can see that the point is going to be in the wrong position. So you need to manually adjust it. And so basically those are the 3 parameters that allow us to make this procedural rules. Even though it is manual, I think it is the easiest method to make this rule. Now, going back into the graph, if you remember for building 3, which is the one we were just looking at, the point level was 17. So if we go to the loop index number 17, we can see now that these nodes are activated. So in here, we're going to go through output P. In here, we can see that we have 6 points. The add attribute will add a new attribute called delete points. And we have an attribute filter that's going to delete the points that has the Boolean value of true. And next we have an add attribute, and that's going to adjust the position. And we're going to go back into the select node that would be using input P. And you can see that every other index is using input and output A. Next, we have the create spline, and that will convert each point into a spline control point, and we are converting it back into a segment because the segment is what we have in the first inputs. So we need it back into a segment, and the output of the segment is going into the feedback and the roof. And the reason it is going into 2 outputs is because one of them is feedback and one of them is not feedback. The difference is the feedback is only one data set. So if we inspect the output feedback, you can see it only has one data set, and it is the output of the last loop, while the roof is just a regular output. You can see that it has multiple data sets, and that's basically one data for each roof room. Now, as you remember, the last node in the roof loop was a spline segment. So now in the next node, we need to subdivide the segment based on the grammar and the modules info. The modules info were created by this subgraph that I've showed you earlier. And you can see that we have additional attributes like mesh connection, and that's going to tell each symbol which mesh it represents. We have the center attribute, and that will place each mesh from the center. We have a rotate vector and the symbol. So roof corner will be rotated 45 degrees on the z-axis and 10 degrees on the y-axis, and that will allow us to make the roof corner diagonal. And we have scale attribute, and you can see that the corner has a high scale, and that's because we wanted to cover the edges of the roof tiles. The vertical size is not used in this case. Okay, next we have selecting grammar, and this will remove corners from inside corners. like this one right here. And the way it works, it takes the symbol and the previous angle. And in the criteria, first, if the roof corner was less than 0, that means it's minus, we will keep it roof corner. But if it was equal or greater than 0, that means it is positive. That means it is an inside corner. And so we will output empty. The other symbols like roof tile and roof tile edge left and roof tile edge right, we're going to say if they are less than or equal to 360. So that means if there were any value, keep them as they are. And the output is going back into the symbol, and the output is a string. So in this node, we will convert it back into name. And here we will match and set attribute based on the symbol attribute. And that will bring the extra attributes that we have here. And we have keep and matched on false, and that will delete the points in here that has the symbol empty, and that will be coming from the selected grammar. So in each data set, we know we have one point that has the symbol empty, and that's basically the corner that is in this corner right here. So now if we inspect this, we can see that the empty is gone, and we have the extra attributes. Now we have transform points, and we are rotating the points by -20 and 90 degrees. Next, we have transform direction, and we are transforming the center attribute by the transform, and we're adding the center to the position. The output is going back into the position, and that will adjust the placement of the mesh so that it is placed from the center. Next, we are adding the rotate X to the rotation. The rotate X is coming from the create module info subgraph. Next, we have an add node, and we are adding to the rotate Y. This is actually a formula that I fitted using Python that will make sure that the roof tiles will rotate with the correct amount depending on the roof angle. So whatever the roof angle is, it will always be the right rotation for the roof tiles. Okay, next, we have an add node, and we're adding the rotate Y, which is the attribute that we just adjusted, to the property rotation dot pitch, and that's basically what will allow the actual rotation of the mesh. Next, we have the same thing. We're adding the rotate Z into the property rotation yaw, and the last thing, we are setting the scale by the attribute scale. The attribute scale is coming also from the create module info subgraph. And the last thing, we have static mesh spawner, and the static mesh spawner is selecting the mesh by the attribute, and that's because in the create module info subgraph we've added the meshes as an attribute to each sample, so that will automatically spawn each mesh in its place. And that's basically the entire graph.